Welcome to the lesson on solving differential equations in Swift Calcs. Swift Calcs has a built-in differential equation solver to help you find solutions to problems involving one or more differential equations. To access the solver, you can enter the solver area in the toolbox and click and drag the differential equation solver item onto your worksheet. Alternatively, from Math mode, you can use the keyboard shortcut DESolve space to add the differential equation solver. When the solver is added to your worksheet, you can choose between two solution modes, symbolic and numeric. The symbolic solver attempts to solve ordinary differential equations or specific equation structures for which an analytical solution is known. To use the symbolic solver, enter the equation you wish to solve into the equation box in the solver. We use the apostrophe key to denote a derivative. In the next box, we enter the function and a variable that we are solving for. Here, we are solving f double prime equals sine of x for f of x. The analytical answer appears after entering the expression. Note that the integration constants are present in the solution. I can refine my solution by providing more equations for the solver to work with. For example, let's define f prime of 0 equals 0, and add another equation for f of 0 equals 0. We click the Add Another Equation link to add our next expressions. As we do so, the answer automatically updates. The advantage of the symbolic solver is that it provides solutions that are fully valid over all of x and can also depend on other symbols. For example, adding an unknown variable z to my expression will update the equation results to also include z. The symbolic solver, however, is limited in its abilities to solve some differential equations, especially problems where the equations do not have an analytical solution. For example, if I change my equation to be solving for f double prime equals sine of f instead of sine of x, the symbolic solver will fail to find a solution. In these situations, we have to use the numeric solver. The numeric solver takes one or more rate change equations, and based on an initial value of the derivatives, marches forward in time up to a final value that you specify. The result is therefore a series of function and variable values over time. Let's change to the numeric solver. The numeric solver solves for a variable instead of a function. To use the numeric solver, we have to think of our second-order equation as a combination of two first-order equations. For example, our unknown function f, its derivative is f prime, and we can think of this f prime as another function g. The function g, therefore, symbolizes f prime. That means that f double prime in our equation is also equivalent to g prime. We can now build our system of equations. G prime, which represents f double prime, equals sine of f, and f prime equals g. We have to provide initial values for both f and g. F, initial value will set to 1. G, which is f prime, initial value we will also set to 1. Finally, we have to provide the start point, which we set as 0, the final point we'll set as 10, and a step size, which we'll set as 0.5. After providing these values, the numeric solver will start calculating and marching forward. It returns a result provided in matrix form, where each row is a particular solution for the problem, and the columns represent the independent variable x and the two functions of interest, f and g. Join us in our next lesson, where we will dive into creating plots and charts in Swift Calcs.